Okay, let's look at number one. Again, we're not gonna do this whole thing. But let's look at number one. A portion of the periodic function g is shown above. Okay, can you figure out what the period is? What do you think? 4. 4 is how many blocks it is from the top of the mountain to the top of the next mountain. Everybody clear on that? Period's 4. So using the graph, find the following values. The period's 4. So g of 9 will be the same as g of 5 and g of 1, right? They're 4 apart.
Yeah.
So it looks like g of 9 is 1. Remember, this is like a function, so we're finding the y value when x is 9. How about negative 12? Negative 12 will be the same as 0, right? And other things too, but it's 3 periods, negative 12. How about 29? What? 1. Right? Remember, the period's 4. So whatever happened to 29 happened at 25 and 21 and da 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 da. Well, in 29 there are 7 periods and left over. So it's going to be the same as g of 1. All right, guys on this side of the room, we getting this now? You okay over here? All right, let's go ahead. You guys do 3 and 4 together. Share your answers with me, and then we're going to flip over and do the back side. All right, Cole's got answers for us. Sharon, Cole, what'd you get?
For 3, I got 9.
Okay, so he thinks the period's 9. What?
No, I agree.
You agree with that? Everybody's got a period of 9? A piece every 9. Perfect. Okay, then what'd you get for 4?
I got 2.
A, he got 2. So H of 13,
I agree
2.
with that.
Yeah.
We agree. B is H of negative 12 is negative 2.
I agree with that.
Wow, Owen's agreeing with you. Look at how. And C,
3.
he got H of 82 to be 3.
I agree with that too.
Okay, good job. I do too.
3 lines.
Does anybody have an issue? All right, backside. Backside. Let's do another one of these. So take a look with your partner and see if you can figure out what's going on in this problem. No, guys, we're on the back side. Oh, no, I'm sorry. The back of the whole packet. I'm sorry. The back of the whole packet. Not right now. We have to get some notes taken today.
I called the actual. I hear what you're saying with that. Saturday? Saturday.
Side of the worksheet with the toy car. Okay, before I start plotting, let's just make a list of what we know. What do we know? Our ordered pairs are going to be time, distance from wall, right? And they tell us what? What does it tell us right off the bat?
Radius of 28.
At time 0, how far are we from the wall? 0. All right, when are we back to that same point again? After 8 seconds. So 8 would also be 0, right? So basically what you're saying is the period of this thing is 8, right? So we could go on, this would be 16 0, and on and on and on. Okay? Now, what happens halfway in between 0 and 8? Well, you're 4, obviously. Where is the car halfway of the revolution? He is 40 inches away from the wall because he's on the opposite side of the circle, 2 radiuses, or 2 radii. So that would be 40. Now, what happens in between there? Well, at 2 seconds and 6 seconds, where's the car at 2? Is he 20 away? 1 radius? He's at the bottom of the circle. And then at 6, he's at the top of the circle, so he's also 20 away. Would everyone agree with that? And we can certainly add more points if we need to. Now we have to plot those. These are the points. Everyone agrees? These are the points. Now I need to get them on my graph. And remember, this is a piece of graph paper. So don't you be putting 0, 0 up there. Right? So we're done. This is there's no axis shown, but look at these y values, guys. What's the highest y value? 40. So doesn't that point have to have a 40? So this will be the point, well, or this one, maybe I'll make this one 40. This would be the point 4, 40. Make either one of them 40. There's more than one answer, but 40's got to be up there at the top of the picture. Now, if that's 440, then what's this one? Oh shoot, I'm gonna have to make this 440. because it's gonna go negative on me, and I don't want that to happen. So we're gonna make that one 440. So then what's this one? 620. And this one is 80. Does that make sense to everyone? 80. And then this guy would be, this would be 1020. Everybody okay with that? And then what would this one be? 1240. Remember, the period is 8. So if that's a 4, this one's gonna be a 12. Now, there are other answers you can have. What I don't wanna do is, when I had the 440 over here, in order to label these points, you see how I would have had gone negative on my X, and I didn't want to do that, because it's time. So I think I will. Okay? All right. Now we're talking about these 2 points this time. Tell me about my curve on those 2 points. We're talking about the curve itself, the function D. What can you tell me here? Positive and increasing. The curve is positive. When we talk about the function being positive, we mean its y's are positive. Alright, and then how is the rate of change changing? Increasing, because that is concave. Very good. Alright, we need to work a little bit more on our notes, and then we'll still have this sheet. We have it available. Mark what we've already done. Okay, let's get our notes out, and we're still in 3-2, and I think we're ready for example 3, which is very, very easy. Don't let the vocabulary and all those letters and all that make you nervous. Okay? I'm just writing this. Find the coordinates of points Q, R, and S in terms of X and Y. This is so easy, guys. So if that's X, Y, what's this one? Negative X, Y. I'm in quadrant 2, so X is negative. What about here? Negative X, negative Y, and what about here? X, negative Y. Super simple, all right? So those are the coordinates. Now, we want to know what the sine of the angle, it would be this angle right here, the sine of the angle that creates point S. What would the sine be? Think of your definitions. What's sine by definition? Sine is y over r. And I don't know what r is. They just told me it's r. So the sine right here would be negative y over r. Why does it make perfectly good sense for the sine to be negative at point S? Sine is y, right? Sine's gonna be negative whenever y is negative. All right, what about the cosine at point Q? What's the cosine gonna be up here at point Q? Negative x over r. And what is the tangent gonna be down here? Y over x. The tangent will actually be positive because both x and y are negative in quadrant 3. you're gonna discover that all of the functions are positive in 2 quadrants and negative in 2 quadrants. So obviously, everything's positive here, and the tangent's also positive here. Sine is positive here, and cosine is positive here, because cosine is x and sine is y. All right, let's take a moment now, get started in part 2. We separated this for some reason. So here we go. Positive and negative angles, we already talked about all that. We talked about how we're gonna measure angles. Now we're gonna talk about what a radian is. Because in our class, everything is done in radians.
I have a question about the tangent. It's opposite over adjacent. I don't understand how the y is opposite.
Okay, so remember this point right here.
Yeah.
Okay, so here's the origin. I'm getting down to this point. So I'm gonna go left x and down y. So this is negative x and this is negative y. This is the angle we're talking about right here. So this would be the opposite side.
How is it not the, like, if you go down one more, like,
This one,
how is it not the next slice down? Like, I don't understand.
how it's not what now?
I don't do negative y and then x first.
Oh, for this point,
Yeah, like how you go down first to make the triangle next to it, to the right.
well, when you plot a point, you always, points are x comma y. Points are always horizontal and vertical. So let's look at quadrant 1, the triangle in quadrant 1. And let me use numbers instead. So let's say we're going over 3 and up 4. And then this would be our angle, right? Now, when I come over here and draw the exact same triangle, this is going to be theta now over here. And this would be negative 3 and positive 4. If I draw that very same triangle down here, here's theta.
Oh, okay, thank you.
This is going to be negative 3 and negative 4, right? Got it? Yep.
It's like a little thing that's confusing to me is how, like, how can, if sine, cosine, tangent all have to do with triangles, how can we find that with theta, if theta is bigger than 180?
Okay, so the reason that we have the circular definitions, that is, we don't think of, it's okay to think of cosine as adjacent over hypotenuse, but that isn't always going to work because trigonometry exists outside of triangles. We're going to be doing problems where there is no triangle, but we still have trigonometry. And that, I get it, the word trigonometry means triangle measurement. So it is definitely tied to triangles, but if somebody says to me, find the sine of 90, I cannot draw a triangle to find the sine of 90. Think about that for a second. It would be a right triangle, right? And that angle right there, this would have to be the opposite side,
Yeah.
but yeah, then it doesn't work. So SOHCAHTOA is a wonderful tool, but it's step 1. We're going to go far beyond that. Now, we are going to spend a lot of time with triangles. I don't want to say we're not. But we have to get over the fact angles can be positive and negative. They can be as big or as small as we want. The sides of the triangle can be positive or negative in terms of the circular definition. Yeah. So you just have to expand your horizons a little bit. Okay. So I need to get to radians though. So up until this point of your life, and even me yesterday, I said I'm going to draw a 60-degree angle. I knew what that meant, 60 degrees. Does anybody know the definition of a degree? What even is a degree? What does it mean to be a degree? Anyone know?
How many eyes are in one?
That's radians. That's radians. Somebody just decided, one of those, I don't know, Egyptians probably, just decided because they were fascinated by the numbers, like 6s and 12s and all that, they just decided, we're gonna take a circle and we're gonna split it up into 360 pieces. And we're gonna call each of those pieces a degree. Now that's kind of random. Could they have decided back in 200 BC or whatever, could they have decided to split that circle up into 400 pieces? Yep. But there are 360 degrees in a revolution for the same reason that there's 12 inches in a foot. It's just is, right? There's no real math behind it. At least with, when we say there's 100 centimeters in a meter, at least there's some kind of math in there, right? But with these other units, they're just kind of made up. So, mathematicians, as math got more complex, decided we need a mathematically based unit. So, they decided that they were going to take a circle with, let's make up a radius. Let's say the radius is 5, right, just made up. If you strike an arc of radius length, so in other words, this is my little scepter I've drawn here. If I make my arc the same length as my radius, that angle is 1 radian. So a radian is the measure of the arc, the measure of the angle determined by an arc of radius length. A radian corresponds to an arc length of 1 radius.
Is it also because you use 2 pi r in
2 pi r comes from this.
oh it does?
Yes,
Okay.
yes. Because if, okay, so there's 1 radian. So what if I drew another radian here, or another 5 here, another arc length of 5? What would this big angle be? 2 radians? And 15 would be 3 radians, and so on. So arc length, so this 15, is simply the product of your radius times your radians. So when we had a radius of 5 and an angle of 2 radians, our arc length was 10. Right? Well, it turns out that all the way around, if you just keep tacking on radii all the way around, the measure of that angle will be 2 pi radians. So 2 pi is a revolution. So your circumference is 2 pi times your radius. This 2 pi is linked directly to the radian measure of a revolution. All of your angles can be changed from degrees to radians using that relationship right there. But we're going to try really hard to stay in radians. If we have to switch to degrees to make something make sense, we will. And we're going to try to stick with radians. So, let's look at example 1 and see if we can figure out what's going on. By the way, if a revolution is 2 pi, then 2 pi radians must be the same as 360 degrees. Does that make sense? And what about pi radians? Pi radians will be the same as 180 degrees. And what about half a pi radians? That would be the same as 90 degrees. So yesterday, when I drew my unit circle, and we're gonna come back to that, and we were in standard position, I had 0 and 90 and 180 and 270, but I also had these measurements. Do these make a little more sense today, now that we've talked about what a radian is? All the way around is 2 pi. Halfway around is pi, quarter is pi, 2, and 1.5 pi's is 270.
How did we find pi?
What?
How did we find pi?
Pi is the ratio of the circumference to the diameter of a circle, and I'm not exactly sure how, I don't know if they did it by trial and error or what they did, because they figured it out long before computers. All right, that would be a good thing to research. All right, example 1, consider the angle right here, this angle right here. The radius of the circle is 4. Okay, that doesn't matter. How big is this angle in radians? Pi over 2. That's easy. How about a third of a circle? All right, now that's a little bit different. Any thoughts on that? We're going to take our circle and we're going to go a third of the way around, which would be like over here maybe.
2 pi over 2.
Third of the way. What did you say?
2 pi over 2.
He says that angle's 2 pi over 3. What do the rest of you think?
Yeah.
It's a third of a revolution, and we know that a revolution is 2 pi's. So a third of it would be 2 pi over 3. Any thoughts on how many degrees that would be?
120.
120. So how did you do that? 360 divided by 3, a third of 360. Very, very good. All right, now our unit circle. This is something else you have to know. All right, so I'm gonna draw it nice and big here. And you might, well, we're getting kind of ahead of ourselves. You might want to turn the page. He's got a nice one drawn there for you. Now, what does it mean to be a unit circle? It means your radius is 1. So without knowing anything, I know that the coordinates of this point, this is 0, the coordinates of this point would be what if that's a unit circle? So that
1,
the
0.
radius is 1.
1, 0.
So this is going to be 1, 0. And this guy up here is going to be 0, 1. And this guy over here is -1, 0. And down here is 0, -1. So those points are like automatic. We have 3 angles labeled in every quadrant. Well, they're drawn, not necessarily labeled, but they're drawn in every quadrant. Those 3 angles correspond to the special angles that you learned in geometry. Anybody remember what I'm talking about? What am I talking about? 45, 45, 90, that was one of your special triangles. So 45 degrees, that would be this line right here. That's 45 degrees. What would that be in radians? We're trying to do it in radians. Pi over 4. We're going to find that coordinate. What were our other special angles? 45 is one of them. What were the others? 30 and 60. 90 is already up there, but 30 and 60 were special. So this one is like the 30 line. What would 30 be in radians? Pi over 6? Does that make sense to you? Pi is equivalent of how many degrees? Pi is 180. So 30 is a sixth of that. So we're going to find those points. And then what about 60 degrees? 60 degrees would be pi over 3 because it's 180 over 3, a third of 180, and we're gonna find those points. Now here's the beauty of the unit circle and why it is such a big deal. This guy right here, right in the middle, that's supposed to be right in the middle of this quadrant. Any thought about what he is in radians? Think about that. What? 3/4. 3/4. And what about this one that's right in the middle down here in quadrant 4 or 3?
5 pi over 6. Oh, wait, no.
Wouldn't this be 1 1/4?
Oh, 5 pi over
So
6.
5 pi over 4. And this one right here in the middle will be, look, we have 1/4, 3/4, 5/4, 7/4. So the middle lines, look how he subdivided your unit circle. Every unit circle is subdivided that way. The middle ones are the fourths, the pi over 4s. You're gonna see why that's significant in a minute. And we're gonna find those points. Now, this one was a 6th. So what do you think this one is right here? What do you think that one is? 5 pi over 6. Because that was a 6th. This is gonna be a 6th. That's a whole pi. So that's 5/6 right there. Very good. Now what about this one? What do you think this one is? Huh? 7/6. And what do you think this one is? This one. 11/6. Very, very good. So in the middle of the quadrants are the fourths, because a fourth is a half of 2. So right in the middle of the quadrants are the fourths. The line closest to the x-axis are the 6ths. So that's a 6th, that's a 6th, that's a 6th, that's a 6th. And then these other guys, okay, so we have that one. What do you think this one is? 2/3. And what do you think this one is? 4/3. And what do you think this one is? 5/3. There you go. There you go. Now all of the angles are labeled. And the first time, I know some kids, when they look at this, they think, there's no way I'm ever gonna remember that. Oh, it is so easy because it's very periodic. It repeats. So you've got your quadrants, those are easy. Split them in half, those are your fourths. Then the little angles, the ones close to the x-axis, those are gonna be your 6ths, and the other ones are gonna be your 3rds. All right, why did you study 45, 45, 90 triangles when you were in geometry? Why did you study those? What do you remember about studying those? 45, 45, 90. You don't remember anything?
It's like S and S root 2.
Okay, so you remember. Here, if this is a 45, 45, 90 triangle, you remember that it was like 1, 1, root 2. I'll use 1 instead of S, but those ratios, right?
Yeah.
Now, this is not a unit circle. This is a circle with a radius of root 2. So what if I divide everything by root 2? Now is the radius 1?
Yeah.
What are the coordinates of this point then? If the radius is now 1, 45-degree angle is going to make what coordinates? I'm going to go right, root 2 over 2, and up root 2 over 2. So the coordinates of the pi over 4, that's your 45-degree angle, are root 2 over 2, root 2 over 2. What does that make the coordinates of this guy over here? He is another 45-degree angle, but now he's in quadrant 2, so his numbers are going to be negative root 2 over 2, root 2 over 2. And how about the 45 down here in quadrant 3? Negative root 2 over 2, negative root 2 over 2. And over here in quadrant 4, root 2 over 2, negative root 2. So what do you really got to remember? You really have to remember that a pi over 4, any pi over 4, is going to be root 2 over 2, root 2 over 2. And then fix the signs, positives and negatives, depending on which pi over 4 you're looking at. See how easy that is? All right, what do you remember about your 30s? You remember that the short leg, or the hypotenuse, is twice the short leg? And the longer leg is root 3 times the short leg? All right, this is not a unit circle though, so I need to make it a unit circle. So this time I'll divide everything by 2. So for a 30-degree angle, what are the coordinates of the point? Root 3 over 2, comma, 1/2. Every 30, which is pi over 6, every pi over 6 is going to have those coordinates with negatives put in.
Oh, did you get root 2 over 2 by like rationalizing?
Yeah. Okay, so pi over 6 is root 3 over 2, comma, 1/2. So what's this pi over 6? Negative root 3 over 2, 1/2. This pi over 6. Negative root 3 over 2, negative 1/2. And this pi over 6. Root 3 over 2, 1/2. So, negative 1/2. So what do you have to remember? You gotta remember that your pi over 4s are root 2 over 2, root 2 over 2. You gotta remember that your pi over 6s are root 3 over 2, 1/2. You can adjust your negatives by figuring out which quadrant you're in. All right, what do you remember about 60? Well, it's just another version of that, right? So 60, is that okay with everybody? It's the same triangle. Just orient it differently. So if I make my radius 1, what are the coordinates at my pi over 3s, which is my 60?
1/2.
1/2 root 3 over 2. And then all the way around. Remember, you are given nothing on the exam. So, I don't know, some of you have good memories, so you can memorize that whole thing. You really only need to memorize quadrant 1, because everything else is just a repetition. So one more time. What are my pi over 6s? My pi over 6s are root 3 over 2, 1/2. What are my pi over 4s? Root 2 over 2, root 2 over 2. And what are my pi over 3s? 1/2, root 3 over 2. You're good to go. Absolutely good to go. Let me show you real quick how easy this is. If I said to you, find the sine of 5 pi over 3? First thing that pops into your head is, that's an over 3, that's a pi over 3. So that ordered pair on my circle, I got my pi over 3's memorized, 1/2 root 3 over 2, but where is 5 pi over 3? Quadrant 4, so my y has to be negative. What's sine? Y over r, what's r? 1, so what's the sign? Negative root 3 over 2. Just like that. Okay. All right, I think I'm gonna stop there. I think we're about out of time. And we got an array. So we still need to do example 3.
It makes sense because this is obviously that's the X, Y, well then